Mm. Good evening, everyone. So let's get started. So the question is like from the lectures only. Okay. So hidden Markov models means it is like sequential events happening. Okay, means like with time or okay. So what happens is like okay. So this can be only linear. Okay, means like one directional only from one node to another. There can be no cycle, no tree type structure. Okay, from one node to another type. Okay, and
Screen is not visible.
acha acha. Sorry. Okay. So this is the structure I was explaining. Means like one node is connected to another node, unidirectional. Okay, and one node can only have one child. Okay, like that. So what it means is like with time, this is progressing. So suppose t equals to 0 here. May not be time, means like any type of sequence can be represented with time. Okay, 0, 1, 2, 3, like that. Okay. Now the Markov property states that like you want to calculate the probability of happening of this event. Okay, given whatever has happened. Okay, so what it means is that suppose p of t3 given t3 oh no given t2 comma t1 comma t0 is equals to p t3 comma given t2. So what it means is that the future that I am trying to predict, which in case is t3, depends only on the present. Okay, that is t2. So that is how they have explained here. Okay, like the future states depend on the past states. Okay, so this is the one. Okay, future state depends only on the current state, that is t2 here. Okay, and t3 is the future state and independent of the other past steps t1 t0. Okay, so this is the idea. Clear? Independence part is clear? Clear, right? No problem. Easy enough. Good.
Sir, could you explain once again?
So, which part like you missed? Means how much did you understand?
The diagram itself, sir.
That's all. Okay. So you have just entered, right? I think Puravi, right? Maybe. Okay. So like the diagram as you see, I have forgot to paste the other questions here. I think. Uh, I will do it right now, no problem. Okay. So the thing is that this is the diagram, which means that means the child of every node. This node means like there's only one child of every node. Okay, and the no cycles. Okay, and directed graph. Okay, so this is the property. Okay, just simple enough, like one after another occurring. Okay, you can always represent it with time because it's sequential data, sequential events. Okay, so t equals to 0, t 1, 2, 3. Okay, so what I want to calculate is the probability of occurrence of t3. Okay, and uh, given that, suppose I first of all don't know what type of event, what type of uh, uh, what type of occurrence is this, how the probability is related. So while calculating t3, I'll also consider that it is dependent on t2, occurrence of t2, t1, t0. But when I came to know that it follows Markov property, what it means is that probability of t3 only depends on t2. Okay, rest rest of the terms it is independent of. Okay, so t3 is explained as the future. Okay, in the question. Okay, so it is only dependent on the present, that is t2. 1, 0 and 1 are the past. Okay, that is why it is dependent only current state, that is present, and is independent of the past states given the current state. Okay, so these are simple ones actually. How did I miss out? Question number 6, 7, 5. Actually, here it is. Okay. So this is from theory that probability distribution can be represented as valid potential functions. Okay. Uh, so okay. So the representation is like this. Okay. Probability of x is given as 1 by z, some sort of normalization. Okay. And product of over C classes. Okay, this is the potential of x at every class. Okay, so this is the representation. This is z. Okay, and probability is not always strictly positive, it can be zero as well. Okay, so 1 is true, 2 is false. Okay, so the next question is this one. Okay, so
So probability cannot be negative, no?
now here is all strictly positive, can be zero as well, right?
Strictly positive, that means it will be false.
It will be false.
Okay.
So miss the options here to find it. Oh, this is also quite a simple question. Like given B, which are conditionally independent of each other. So in undirected graphs, what happens is that uh, so if the middle one is known, okay, so then you cannot reach to other node through this, okay, because there is no dependence there. So, okay, so as you can see, like C and D are separated with B, and also E and C here. Okay, someone is asking to join. Hmm, right. So like this you can say as a like a good question type. Okay, so how will you occur at this is like, first of all, you can see that like if probability, okay, let's start from here. If probability x is known, okay, but still, how are you going to write this one? If probability of x is, means this is the probability of x first of all, okay, breaking it up, okay. So when I write it up, it means that x is known, okay, but still, okay, it will be dependent upon x, okay, and p of z, what will be? Acha, p of y given. Acha, acha. Acha, acha. This actually will not work, okay? Because what happens that if you're writing probability of y now, you have to write the probability of z first of all, okay? Then only you can represent this, okay? Represent the joint probability, okay? So this is the correct expression if starting with p of x, okay? And so this is not given here. Next, p of y, as you can see, what happens that when you know p of y, x and z are independent of each other, okay, so x is only dependent on y, and similarly z is also only dependent on y, right? So this is the answer, okay, but like let's check for other options as well. So this one is simple, similar to this one, okay, just replace x with z, okay, and you can do similarly, okay, and this one is by the logic that if you write the py, then you have to write the probability for x and for z, okay, you cannot keep writing y, okay, that is why this one is incorrect, okay, clear?
So not clear, sir. Both what you have written both are correct.
No, yes, this expression is correct, but this is not an option as you see.
Yes, but it is correct. Correct form.
It is correct.
Can you explain this form again?
So like by theory of probability, what is this? P of x comma y, okay, when you attach this, what is this? Just theory of probability, okay, P of x, okay, you know this one, right? Joint probability is equals to Joint probability means this intersection type. Okay, so this is px multiplied py given x. You know this, right? Conditional probability. You know this, right? Conditional probability of y given x
Yes.
is to this intersection divided by px. Okay, just I have written like this. Okay, so this intersection is only the joint probability. Okay, so this is the p x comma y. Okay, then you can use it similarly with this. Okay, to get this. Okay, clear?
Sir, I didn't get the second expression, last one. This P of Z condition Y.
Means
Z
like
given.
you can say like x occurrence, as you see the occurrence of x and y both, it is similar to occurrence of like x here. Okay, understood?
No, no, I'm asking about second expression.
Second expression, this one,
This one, the last component.
last,
Z,
this one.
Z
No,
of Z of Y.
yeah,
Yes, sir.
what happens is that when y is given, x and y are in, or x and z are independent of each other but dependent on y. Okay, this is the in the middle, as you see. Okay, if it is given, then x and y are independent of each other. So as you see, expression in the expression of x, what z does not come. So in expression z, x does not come. Both are dependent on y. Okay, so this is based on theory. Okay, again undirected graphs. This is what happens. Okay, just for clarity, what you will write here: y p of x given y, and p of z given y comma x. Am I correct or not? No, no, no. You can write it on only in this ways only. It's like if y is given, okay. So what will happen that you cannot relate to any parameter x and z, okay. So they're independent of each other because the interjoining node is already known. So just you can remove this y, x and y are x and z are independent, okay. But they are both dependent on y actually. Whatever be the value of y decides the value of x or z.
Sir, is the Z dependent on X and Y both, or only X? Sorry, only Y.
Only y. Similar that x is only dependent on y, so z is only dependent on y.
So in the first expression, third component, you write PZ condition given X and Y. Y on not only Y.
What is
First
hmm.
expression, third this one.
Third.
This one.
Okay.
So
So
we can write P of Z given Y, no?
no, no, understand. Like if x is known, then what happens that x means like you understand. Like it is still dependent on y, z is still dependent on y, and y is still dependent on x. Okay.
Yes, yes.
Okay. Overall easy means like just probability actually means like this lecture does not have like much machine learning. It's just probability theory. Anybody who has it clear, like very easy for them. Question number 4 done. This is question number 3 and 5 here. So okay, so the idea is that probability of E, what is it going to be? E given small e. Okay, it is summation over. The summation represents marginalization. Okay, the summation on everything except E. Okay, so the as you know by probability, that if you sum a probability distribution, okay, over all the values of a particular variable, okay, what you do is that the final expression is independent of the independent of the value of that variable. Okay, it is called sum rule of probability. Let me explain maybe. It's actually more important to explain than the question actually. Because if you understand, then there is no problem. Okay, so this is the one. Maybe not that clearly written here. Okay, maybe this is the one. Not very well written here as well. On biology type, but it will work actually. No, no mathematical expression here. Another problem. So whatever, what can I do? So given suppose a joint distribution this, okay, A and B, if I sum over all values of A, okay, of the distribution given, then what I get is P B. Okay, so this is the idea. And like if there are C and D and like that, so summation over C and summation over D. So what I'm doing is to get this one, what I have to do is summation over all these variables, okay, we should remove all these four variables, only left with E. Okay, simple enough. So summation over this quantity, as you know, understand, like everything other than E. Okay, and what I have here is the joint distribution A B C D, everything. Okay, like that. Okay, so this can be written like P as you see that A is independent of everything, so PA, then P B can be written as B given A, and P of C can be written as C of BA V comma A. Okay, so what happens is that like you have to marginalize with respect to A first. As you see, if you get A as a given quantity, okay, then what happens that you can calculate, okay, calculate, okay, means like this expression, what does it mean? That given A, so for A has to be given, the A P of A value has to be known. Okay, okay, so then you can marginalize with respect to B here, then you can marginalize with respect to C here, dot 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 up to D, then you get the value of E. Okay, so this is the idea actually. As you can see, sum over A B C D. Okay, so when I put so the uh, summation will distribute. Okay, as you see, this has only A, so only summation over A, summation over B or C doesn't matter. Okay, so like that you have to do. Okay, got it? Any doubt? Means the idea is like try start with the simplest one, so that others like as you can see B has only dependence on A. Okay, so if A is known, then you can marginalize over B. Okay, like that. Then C, B and A are known. Okay, so marginalize over them like that. You have to progress. If you start with some suppose D, what happens then the A, B, C are unknown. So you're calculating E will also depend on A, B, C. Okay, so that will be hard. Okay,
So
okay.
answer will be A B C D.
Hmm. Okay. Start with the quantity which is not dependent on anything. Okay, that is the idea. Then,
Sir, if it is a complex structure, then it is a simple line structure. That's why we can say easily.
but still the graph will start from somewhere. Suppose I in this
So
graph
then
we start
only
with
the
5.
first component will be fixed, the which is the parent component,
Yes.
and then we
So
can
start
write it.
marginalize with 5 first. Okay. Then with 4, 4 or 0, whatever you choose, equal.
Okay, okay, okay.
Then 1.
Then we can one, two. Okay. So first parent component will be fixed, then we can do.
Hmm. Okay. So which question was this? Question number 5. Let's go find question number 6. And this is the one. Which is the method for conditional probability? So as you see, the variable elimination, that is what I have discussed right before. That is the marginalization. Okay. So with this, you can calculate the conditional probability like this. Okay. So this is M1 answer. And belief propagation, as you can see in the theory, like some knowledge is delivered. It is like a bias. Okay. Through which you can calculate the conditional probabilities like that. So question number 7 now. So again, similar question. So 3 and 2. Okay. So as you can see, like if so means like the middle, if the middle node is known, okay, so they are independent like that. Okay. So if 0 is known, then 3 or 2 are independent. Now 0 and 4, as you see, there are two middle nodes. Okay. So one being known does not make the two independent. Both 2 and 5 have to be known, so that 0 and 4 are independent. Then 2 and 5, as you see, 2 and 5 has also both nodes 0 and 4. Okay, so both have to be known to make them independent. Then 1 and 5. Okay, so as you can see, only 4 is there. So this is another answer. So answer is this and this. Okay, any doubt? Any doubt? So what I'm doing is like if the middle node is known, as you saw in that example. Okay, so this is the example. If y is known, then x and z are independent of each other. Okay, so that's the theory actually here. So if the middle node 0 is known, okay, that is middle between 3 and 5, then 3 and 5 are, uh then 3 and 5 are independent, but not in the option. Okay, 3 and 2 is given, the middle node is 0. Okay, so 3 and 2 is independent. 0 and 4, two middle nodes are there, 2 and 5. Okay, so not independent. And so as you can see here, that given a single node. Okay, uh, so like that actually, very simple actually. Any doubt? Okay, let's move on. 7 is the last one here, I think. But other questions are there. So this is like a good question, as you can see. But still easy actually. So the idea is means like the Bayesian graph is given. Okay, so you have to calculate this probability. It's just you can see it is a joint probability, right? Okay, and this joint probability can be written as in what way? Like P of D, it is independent of everything. P of I, it is independent of everything. I actually, oh my god. P of G given D and I. Very easy, right? You can very easily write this one. Then P of S given I, P of L given G. Okay, so the joint distribution can be broken like this. Okay, so how to do it actually? Like, so I'm starting with D, as you see. Okay, so from this joint distribution can always be broken in this way. Okay, let me explain another slide. When the general way is like this, suppose X, Y, Z is there. So this can be always written like P of X first. Okay, means one variable you have to take first. Okay, then P of Y, as I've already explained in another question, X. Okay, P of Z given XY, and it continues like that. Okay, okay, this is the idea. If like Z, then P is also there, then probability of P given X, Y, X comma Y comma Z. Okay, like that it will continue. So I start with D because it is independent of everything, as you see. So this is P of D. Okay, and what will be the next one? I next one I've taken intelligently as intelligence. Okay, so these two words I've used same. So so the idea is that intelligence is also independent of difficulty. Okay, so means simple to turn complicated, like that. That is the idea. Or maybe you can say that from starting from parent and going to the child, that should be the intuition. So I start with D, means given this formula I can start with anything, right? I can start with Y, I can start with Z, I can start with P, but I have to take which is independent type or maybe least dependent on any entity. Okay, so P of D, then P of I. Okay, so this actually is P of I given D. Okay, but D I is independent of D, so you can actually write as P of I. Okay, so then P of G, so this will be P of G given D comma I. Okay, so those two quantity has happened, so this is like that. Okay, this is P of S, that is given I D G, but it is independent of D and G, so only I. Okay, then P, this will be P of L given G S I D, but it is only dependent on G. That is how I've simplified. Okay, and after that there is nothing much actually, just P of D, as you can see. So they have asked D to be 0, so what will be 0.6? Okay, probability is 0.6. P of I, I given 1 is 0.4. P of G given Di. So probability of G given D and I. Okay, so D is 0, I is 1. This is the one, right? And G value has to be 2. Okay, so answer is 0.08 here. Okay, S given I is 1. Okay, and S has to be 1. Okay, so this is 0.8. Next is L given G. So what is L here? L has to be 0 and G is 2. Okay, so 0.4. Just multiply this value, you'll get the answer. Acha, can you explain how the factorization equation for this? Uh, which part you're asking for, Ajay? Which question? This is the question?
Sir, same question which you explained, this difficulty intelligence.
Yeah. So you can see the slide.
Yeah.
Important thing for you to understand that we are not actually marginalizing here.
No,
Okay.
no, sir. I'm asking
Hmm.
how we can write the marginal probability equation for example, letter in the given example.
Acha. So what will you have to do? Summation over all the rest. Okay. And
Yeah.
start from difficulty, then intelligence, summation over. See, summation over all these values of D over D. What will you get here? What are the values of D here? Okay. So I add this, it will get 1. Similarly, you'll get 1 here. Okay. Clear?
Yes. For D and I, it is one.
Hmm. So after that, what you're doing is like you are marginalizing over G, right?
G uh, probability of G with D and I,
Hmm.
given D and I.
Given D and I. So actually means like you have to sum over this full expression actually here. Okay. And what you're going to do is that suppose like D is 0.6, I is 0.4, and G is like that. Okay. So to calculate all the sums here. Okay.
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 Thank you. Sir, one more program is there.
Hmm.
In assignment 8, question number 5, the solution provided, it is solved for,
Question number.
solution is given. Question
Acha.
number 5.
No, actually, this is old one. So let's see. Week 8.
Question number 8, assignment 8, question number 5. Yeah, this one. This one. So, in this, the solution provided to us for multi-storied, but in the question it is asked not multi-storied.
Acha. Then solution must be wrong. Just use non-multi story. Okay.
हाँ, no, no. इन द सेम उसमें जो स्लाइड असाइनमेंट 8
Hmm.
है, सॉल्यूशन इज गिवन,
Okay.
जस्ट शो द सॉल्यूशन.
Solution. Acha, this is not
In
the
the
one. This is
it
wrong.
is the announcement.
It is given
In the announcement, you can see.
solution this one 8.
You
You
have
can
to
check.
do it similar to that phone and network. The phone question was there, right?
But it is evaluated with this given solution.
Acha.
And
Then
if we consider the not multi-storied,
then another answer you're getting, right? So they will correct, okay?
yeah, yes.
They will correct nothing. Sorry.
Yes.
Sir, actually, I also have the same question, sir. I solved and I got probability of office is highest one. So the answer must be office only, no, sir.
Acha. Means like they will correct line. Okay, no worries, no doubts.
Okay, sir.
Checking in the announcements. This we have got, okay, and question here. Mhm. So that will be you're correct in that. So they have used here
Yes,
multi-storage.
sir.
They have used there here multi-storage. Okay, that is the problem.
But yes, sir.
Hmm.
But in the question, it is given not multi-storied.
Mm-hmm.
So the probability is 2 by 5. This term must be 3 by 5.
Mm-hmm. Correct.
So all the three probability will change. So for that, office will be the highest probability. So the answer
Yes.
must be office. B.
Yes. Yes. Correct. So this will be corrected. No problem.
Okay, sir. Thank you.
Okay, and not much is left now. Okay. So So the idea is that given D, okay, here what they're explaining is that given D, A and B are independent. You can see like means like in the right hand side they've removed B. What it means that writing B or not writing B makes the same sense. So it means that A is independent on B. Okay, given D. Okay, so this is the idea. But this only occurs, okay, A and B are independent only when C is not known. Okay, now C is known. Okay, C is known. No, doing it wrong. Sorry. Well, when C is A and B are independent.
A and B will be
Yes,
independent,
yes, yes,
not given C.
yes. When C is not known. Okay, in directory graphs, that is the theory when the means like C is the child of both A and B. Okay, so if C is not known, then A and B are independent. Okay, from this theory we do that. Okay, and also like that claim B as well. Okay, C is not known as you see, so A and B are independent. Okay. Mm. So here what happens is that
What is the answer, sir?
Acha, answer is this, both are correct actually. Any doubt? Both the cases C is unknown. Okay, D is irrelevant here.
But there is no C. They are not mentioning about C.
Yes, so that is the idea. If C is unknown, then in directed graph, okay, A and B are independent.
So it is no C is not mentioned. That means C is not known.
C is not known. Okay.
So second one is true. But how the first one is true?
When in the first one they have just added the D part, right? So D is actually irrelevant, okay? D is not connected to both A and B.
So can we say that if D is known, then C is also known?
No, no, no. If D is not known, then C known you cannot say.
The first option it is D mentioning. That means D is known.
Mm-hmm.
So if D is known, then C is also known.
How?
This is how I explained the previous problem solving session.
In the previous problem solving session, I have explained this.
Ah, yes, sir. So they have explained that since there is an undirected path from A to B via C, so
No,
it
no.
is false.
As you can see, like directed. Okay, it's like I should remove the.
Same figure he is also showing that. Same figure he is also showing.
He means who?
That is our problem solving difficulty. First problem yesterday.
Acha. Then like means if D is
The
known,
reason what he is given that since there is an undirected path from A to B via C, that's why it is false.
like it cannot be false. Like maybe you're doing some mistake. I think. You don't recall it. Maybe it's like answer is here. Acha. Answer is gone. So maybe I've done mistake. A is incorrect. Acha. So what is the idea here is like C is known in this case. If D is known. Oh,
D is known, that means C is also known. Or E is known, that means C is also known. Is that
acha,
correct?
acha. I think like in this way means probability of D, okay, it will be what? Marginalization, that is summation over to write it from A, I think, probability of A, and then what I'm trying to do is like C given A comma B, okay, E is not needed, okay, and then P of D given C A B. To get probability of D, C has to be known. That is the idea, right? So what it means is like, acha, acha. So it means like when you're marginalizing over C, it means that C is known, right? Acha, acha. Got it wrong actually. Okay, okay. He's the one who's correct. Okay.
So A is correct. No? A is false.
A is false. Yes.
So what does it mean? The undirected path from A to B via C.
A to undirected path very well saying.
No, the reason what he given. That's why.
Undirected path is not the directed all. Okay. The idea is that marginalization. To marginalize over C, all the values of C are, has to be known to know the value of D.
So that means if we know the D, given D, then C is also known.
Uh-huh. Yes.
Same thing for E also.
Same thing for E also. Coming from this expression, okay? Like to calculate this D, C has to be known, right?
Yes.
That is the idea. So, like Arijit, you can explain this one. Arijit is the name, right? Uh, this one, question number 3. Undirected in place of directed.
This is undirected, no?
Mhm. So, how will
So
we approach here?
if C is known, that means it is blocking, and the parent component will be with the independent.
Huh. See, if C is known, then A and B are independent, right?
Independent.
First
And
one is
D is E and also independent. A and D also independent. B and C also independent. B and E also independent. If
so
C is
very nice. Okay. So like you can like break down the first part like that. Okay. So as you see, C is not known here. Okay. So A and B are not independent.
yes, so it is false.
So it is false. Okay. And next you see that if C is known,
If C is known, then it is
A and B are independent.
dependent.
Independent.
If
Okay.
C is known, they are dependent.
Independent.
Oh, sorry, independent.
Hmm.
Blocking the paths.
So as you can see, like if we the expression we can remove the B, then it means that writing the B or not writing the B makes
Yes.
same
A
sense.
and,
So what it means is independence.
A
Okay.
and B and independent, they are asking, but it
Hmm.
is they are independent if C is known.
Okay.
So it is true. It is true actually.
Okay. So like I should write like this. Got this doubt.
It is true. The expression is true.
Okay. So like, what do you feel about this week? Maybe a little easier if probabilities are clear. Not much machine learning. Mostly like probability type. Machine learning probability is very important. So overall we are done actually. Nothing much. 1 hour. Okay. Any question or something you have to ask?
Sir,
Sir,
how can we get the previous year's assignment question solutions or Asian questions?
Oh, well, like I'm a TA, so I get that I have access to that. That's how it is.
Is it available in the Google?
Means like only available to TAs actually.
Okay, okay.
Uh,
So we cannot access this. Mm.
sir, could you solve assignment 9 questions?
well, that's what you have to do. But okay.
Thank you, sir.
So they're talking about removing one edge, okay? So that the resulting graph B and F are independent given A. Graph B, in the resulting graph B and F are independent given A. B and F are independent given A. Acha. How many are in the middle, right? Acha. So as you see, like C and E are also connecting nodes here, connecting E, F, and B. Okay. I think I give the answer only. Okay. Okay. But you got the idea, right? Means like for that theorem to happen that F and B are independent, the middle node should be known. Okay. So what they're saying that you're cutting the graph means like you are removing edge such that such that that given A, F and B becomes independent. So means like in this question, as you can see, this should be the reference question. This is the one. This is the one. As you can see, 0 and 4 they are not independent even if 2 is given because 5 is unknown. Okay, so you have to think on these lines. Okay, and you will be able to reach to the solution. So next, they're deleting one node and also delete the edges incident with the node, means that that are connected to the node. The resultant graph B and C are independent given A. B and C are independent given A. So as you can see in this B connecting nodes are A and E, so you have to do something with them only. Okay. Markov blanket, like you can see from theory, like well, I don't remember too much. Markov blanket. So this way Bayesian network is given. So which independent relation holds? Okay. So the idea is very similar, like very simple actually, and you have to approach the problem like this. Okay, as in the last problem, you've broken down. Okay, like that. So as you can see, G is dependent on D and I, but not dependent on other entities. Okay, like that. Okay, you have to break down, and given this expression, you can infer whether infer about the independence thing. Okay, just like you have to start from A and B. A and B are independent. Okay, then C is dependent on A and B, like that. So if I tell, then you do the answer. So question number 4. Assume that every variable is binary, means 0 and 1. Okay, what is the independent parameter required to represent all the probability distribution? All the probability tables. Acha, how many independent parameters are required to represent all the probability tables for the distribution? Acha. Well, this may be a good question, okay? But you have to infer from again from this question only. Okay, so this is the probability table. Okay, so this is like a reverse question for this question. So binary means 0 and 1. Okay, so as you can see, the 0 and 1, 0 and 1 type. Okay, and how many independent parameters required? Okay, all the probability tables Acha. What it means properly. Independent parameters. Represent all the probability tables. Acha. So somehow what it means that probability table is given, okay, and how many independent parameters do you need to, okay, so what is it saying, like independent parameter. So this is the independent parameter, right?
So independent parameter means first two parameters, no? Parent parameters.
How? First two parameter, which one?
In the question or here in the difficulty and intelligence of the independent parameter.
But the numbers are high, as you see. But what do they mean to say?
That's why I'm thinking. If A and B from if it is not given and
A and
anything,
so A and
so
B are
it's
independent, okay, but I
independent
think
parameter.
number of independent parameters, okay. So parameters, what do they mean? So as you see, like when calculating this, suppose the probability of G given Di, probability of G given Di, what it means that D and I are parameter here, okay. Got it?
Okay.
So so uh so what can happen is like D and I are parameter. So how many independent such maybe pairs are required here? Maybe four here, as you can see, like this, okay. Okay. This is two here, okay. What parameter is saying? Parameter values are not important, right? Parameter independent is two only here.
It is depend on the values. Or I think for suppose G 1 2 3 are there. So how many variations are there? How do we know?
Maybe asking like that only means question is not super clear here. What is the number of independent parameters required to represent all the probability tables for the distribution? Sure.
Suppose for F we need C, AC, and D, or only C.
For F we need a C, A, C, and B.
So three parameters.
Uh,
For E also same three.
but you can understand like C is not independent from A and B.
Yes.
But of independent parameter. Can it be said like three independent parameters here? Or maybe this is another one. This is another one, I think. So now, but I is similar. One question I'm not super clear about. Maybe should wait for the solution in this one. So variable elimination is marginalization. Okay. So simple enough, I think. Deep into it. Valid factorization. to calculate the marginalization. Okay, you have to check whether it's valid factorization. Valid factorization only means that it should satisfy this structure. Okay. Okay, so this one is doable, very much doable. Okay. Okay. MRF given value should the following satisfy the independence assumption given represented by this MRF. Acha. So what they're doing is like they're writing the independence assumption. Acha. Acha. So Z is the normalization here. Okay. Uh, and so this is undirected graph, so little difficult. Okay. And what happens is like so to take the independent assumption. Okay. So the independent assumption would be like this: if B is known, then A and E has to be independent. Okay, like that. Okay. So this first one represent if B is known. Okay. Then A and B has to be A and E has to be independent. B is this one. Okay. So A and E are independent, right? They're different. A and E are independent. Yes. So this is correct in that sense, I think. So that is how you have to do it. Okay. If D is independent, okay, like that. C is given here, so C is independent. C is given, okay. So then A and B are independent, okay. So you have to do like that, okay. This is not correct, I think. How is the representation? Okay, you have to do like that, okay. Representation, I'm not fully sure how to
Sir,
do.
none of the parameter is given.
Hmm?
Is there any parameter is known here?
No, you have to interpret like that. It's like this phi 1b, okay. So when it is first used, so it means that B is given, okay, like that. Breaking it up like that. This means this
Okay,
C is given.
okay,
This
okay,
means A and B both are given. A and B both are given like that.
okay.
A and
What about the shy two? Shy two A C D.
okay.
Second of
So it is like means like I'm looking at the probability of B and D given A and C. Okay, like that,
okay, okay.
like that. Okay, and after it has occurred, like B and D has also occurred, and A and C both has occurred.
Then
So
four of them are known, and what is the probability of B and
between
E?
B and E, like that. Okay, that is the idea. Got it.
Okay.
Hmm. So that is how you have to do it. Okay, means the first term that has been separated means that it is given. Okay, after writing that probability for means the as you are calculating this A C D. Okay, then that time B is given and known. Okay, so hidden Markov model three times steps are given. Okay, so what what these x1 x2 x3 are the labels. Okay, and y1 y2 y3 are the matter which has to be labeled. Okay, so yi is, so I think I given the answer already. So you have to think like that. Okay, x values are labels, y values are the matter which has to be labeled. Okay,
So what is I here?
I, what are you saying? Acha, I means this sequence, as you see, 1 2 3, as I have used t there. Okay, okay. And just let me explain maybe. So in NLP, one work is to, so given a sentence, I am a good boy. Suppose like, so what is I? I pronoun. Okay. good is a adjective, okay, like that. So these are, so I am a good boy, this is a sentence, and each is a word, okay. And that I am saying that I is a pronoun is a part of speech, okay. So the labels, what I means is that the part of speech, and the matter which has to be labeled means here the words, okay. So means the first one is correct, okay. So I said that one, okay. Rest you can do, I think.
Sir, last option also correct, sir. But the
Like
same
how
point.
much I'm going to tell. Maybe I can tell as well, like you have told already. So as you see, so y values has to be are observed and x are predicted. So very correct actually. This is also correct. Will I get answer now? Let's see the solution. No solution given. Acha. Okay, so we'll be parting. Okay, now the it is simple enough this week. So okay, thank you everyone. Thank you.
Thank you, sir.
Okay. Mm.